Today's lesson is on transformations, but this actually kind of goes back to our families of functions that we did last week. So let's start with our families of functions. So when we talk about transformation, we talk about functions in the form y equals a f of x minus h plus k. And so these transformations can be done with any function. So the first function that we talk about is linear, and we know that's our straight line. And so when we talk about the parent function for that, that is y equals x. Square function, these are your quadratics. So we would look something like that, and that would be our y equals x squared. Our square root function, remember that's kind of half of our quadratic on its side, and that's y equals the square root of x. Absolute value function, that's the one that looks like the v, and that's y equals the absolute value of x. Then we have our cubic function. So it looks something like that. That's y equals x cubed. So all of these are our parent functions. We have a cube root function, which looks kind of similar, just a cubic kind of on its side. So it's y equals the cube root of x. And we have our greatest integer function, which is like our step function. And that's y equals, this is the one that looks like it has the double brackets. And it looks something like that. So these are all our common families of functions that we would use, and they were going to be doing these transformations too. So we have what's called rigid transformations. These just change the location, but the basic shape of the function does not change. So if you add or subtract a number at the end, that's our shift up and down. So if we add a number, it shifts it up. If we subtract a number, it's shifting it down. Those are your vertical transformations. Your horizontal transformations, if it's subtracted on the inside, so x minus c, that's actually a shift right. So it's kind of opposite of what you think. If it's a plus c, then it's shifting it left c units. So these are your horizontal transformations. We also have reflections. If you have a negative on the outside of the f of x, that's reflecting it across the x-axis. A negative on the inside, though, is going to reflect it across the y-axis. So these are all rigid transformations, changing the location, but the basic shape is staying the same. Then we have our non-rigid transformations. These are transformations that are actually going to change the shape of something. So if you have an a value, which is the number in front of the f of x, that is greater than 1. That's a stretch. If that a value is between 0 and 1, then that is a compression. So it compresses it. So the way I teach my students, and I say, think of a piece of Laffy Taffy. If you pull that Laffy Taffy, it stretches it. So what does it make it look like? It actually stretches it out. It makes it look skinnier. Whereas if you were to smash that piece of Laffy Taffy, it compresses it. So it's going to make it look kind of fatter if you're talking about a quadratic. So a compression sometimes is also called a shrink. So it kind of depends on what textbook you are looking at. So let's look at some examples. Okay, so when you are talking about your transformations, we're going to talk about this first one, which is a quadratic. This is actually a shift left 5 and down 4. Well, if you think of your basic quadratic function, your basic quadratic function has a vertex of 0, 0. So what we're doing is we're moving it left 5 and down 4. So left 5, 2, 3, 4, 5, and down 4. So we're not changing the shape. The shape should still look the same, but you're changing its location. The next one is a reflection. It is a compression of 1/2, and it's shifted up 6. So compression, remember, it's smashing it. It's going to make it look fatter. So the reflection is going to flip it over the x-axis. So if we are looking at this, your basic function for an absolute value, again, has a vertex there at 0, 0. So we are shifting it up 6, so up 6. And we are reflecting it, and we are stretching or compressing it of 1/2. So we're going to kind of make a little point here, and we're going to look at this. It's going to look something like that. Now, it also talks about stating the domain and range. So if we are looking at this top one here, the domain of the function that we just had is going to be negative infinity to positive infinity. The range of that function, though, would now be -4 to infinity. Remember, square bracket means it can be equal to that. We're looking at the next one. Again, our domain is negative infinity to positive infinity, but our range on this one would be from negative infinity to a +6 with a square bracket. We're going to skip that next one. We're going to look at our square root function down here at the bottom. This one is a reflection as well. It is going to shift right 3 and up 1. So if we are looking at this one, our basic function, our parent function for a square root function looks like this. It would start at 0, 0. So what we're moving at right 3 and up 1, but it's going to reflect it. So it is going to go something like that. On this one, your domain, your x values that you can use would be from 3 to infinity, and your range would be from negative infinity to 1. So we can also go the other direction. They can give us a parent function and ask us to write the equation. In this case, it says it's translated 5 units to the left and 12 units downward, and we're doing a square root function. So we'd have y equals the square root. 5 units to the left would give us x plus 5 and down 12, and that would be our function. The next one says translated 13 units to the right, 6 units downward and reflected across the x-axis. So we have y equals negative, you'd have a parenthesis, and to the right would be x minus 13 squared, and then 6 units downward, so -6. The last one's an absolute value that is reflected in the x-axis, stretched by a factor of 3, 7 units to the left and 9 units downward. So we have lots of things going on here. We'd have y equals negative, absolute value. It is stretched by 3, so we do need a 3 in front of that absolute value. Then we would have translated 7 units to the left, so that would be x plus 7. Close your absolute value, and 9 units upward. So here, this is your introduction for transformations. If you need any help, please send me an email or shoot me a text. I'll be happy to help you. Have a great day.